Talk about the counting principle and permutations. We're going to start with the counting principle. And the first thing they want us to do in this lesson is write a tree diagram. We're going to draw a tree diagram. There's probably typos in this, so if there are, let me know and I'll try to fix them. It says you are ordering t-shirts for a school organization. You have the option of a yellow, blue, or green t-shirt that comes in the sizes small, medium, large, and extra large. How many t-shirt choices are possible? All right, so we're drawing a tree diagram. That's so funny. Sorry about that. Anyway, how many t-shirt choices are possible? So we're going to draw a tree diagram. And I do mine sideways. Some people do it from top to bottom. I do them sideways. So for our shirts, we have what colors we could choose?
Yellow, blue, and green.
Yellow, blue, and green. So I'll just take one category, split it up. So if I have a yellow t-shirt, I have how many sizes could I use? Small, medium, large, or extra large, right? So I could have, I'm gonna use abbreviations: small, medium, large, or extra large. So I could have blue small, blue medium, blue large, or blue extra large. Or I could have a green small, green medium, green large, or green extra large. So how many t-shirt choices are possible? Well, you just count across the bottom. I could have yellow small, yellow medium, yellow large, yellow extra large. Right, so 4 for yellow. How many for blue? 4. And then 4 for green. So how many altogether? 12. So if they want you to list them, you would say yellow, and I abbreviate: yellow small, yellow medium, yellow large, or yellow extra large. Blue small, medium, and blue extra large. And then I have a green small, green medium, green large, and green extra large. Okay, so if you have to list them, use abbreviations. So that's a tree diagram. Y'all see how we did the branches? And there's multiple variations of tree diagrams. The book does it even a different way. But if it wants a tree diagram, it just wants branches. Okay, and then you list them. And if you list them with abbreviations, that is fine. Okay? BM, bowel movement. Ha ha ha. It's nursing terms. Ha 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 ha. Okay, so let's talk about the fundamental counting principle. So if they just want the number and they don't want a tree diagram, it's really, really easy. You take the number of options you have in each category and you multiply them to get the number of possible outcomes. So that's the fundamental counting principle. You multiply your categories. Okay, so we up there with the t-shirts, we had 3 different colors of t-shirts, 4 sizes to choose from. 3 times 4 equals what? 12. And that's how many we got, right? I didn't write that down. 12 possible outcomes is what I meant to write. 12 possible t-shirts. Okay. So if they just want the number and not a tree diagram, then you just multiply the number you have in each category. So here's an example of that. A sporty goods store offers 3 types of snowboards and 2 types of boots. How many choices did the store offer for snowboarding equipment? So you just multiply the number that you have in each category. How many options do we have for snowboards? 3. How many options do we have for boots?
2.
So we can have 6 total choices. So you just multiply for the counting principle. You multiply how many you have for each category. No. It's really not. Example 2, at the bottom of the same page, you are framing a picture. The frames are available in 12 different styles. Each style also comes in 55 different colors. Then you also have 3 options for your matting. How many different ways can you frame the picture?
12.
Times?
55.
Times?
3.
That's it. 12 times 55 times 3. You just multiply all your different categories together. We've got our calculator. So how many possible ways can we
1,980.
That's right, 1,980 ways to frame the picture. Now, I'm putting words with my answer because there's words in the problem. So word problems need word answers, right? Word problems need word answers. So don't just say 1980, okay? 1980 what? Monkeys at the zoo? I mean, come on. You got to say 1980 whatevers.
We do it like the line.
You can write it down. Word problems equal word answers. All right, let's talk about some more counting principle stuff. And these are with repetition. Okay? So let's talk about a license plate. The standard configuration for a Texas license plate is 1 letter followed by 2 digits followed by 3 letters. Okay? So I'm going to make up space for everyone. I need a letter, 2 digits, and then 3 letters. So 6 characters total. Right? Now, how many letters are in the alphabet? You don't know that there's 26 letters in the alphabet. You need to memorize that. Okay? 26. All right. So, what are digits?
Numbers.
What numbers? Ha. Okay. So, digits are what numbers specifically?
What number?
1 through 9. Well, actually,
0 to 9.
0 counts, right? So 0 through 9. So how many digits are there? How many different digits are there? There's 10 digits options. Okay? Well, there's 0 through 9 because 10 is not a digit. Yeah, because digits only take up 1 space, right? Yeah. Yes, I get what you're saying. But you see what I'm saying, though? Like, digits are only 0 through 9 because digits only take up 1 space. All right. So to find out how many different license plates, this one says the digits can be repeated. So that means I can have 2 A's in my license plate number or 2 6's in my license plate number. Okay? So what I've done is I've labeled, I need a letter here, a digit here, a digit here, a letter here, letter here, letter here. Is that right? 1 letter, 2 digits, 3 letters. That's right. Okay. So what you're going to do in each blank is you're going to put how many options you have. All right. So how many options do we have for letters? 26. And these can be repeated, so we'll fix that in a little bit when they can't be. How many options do we have for digits?
10.
So that needs 10 and that needs a 10. And then we have how many options for letters? So I keep putting 26s for all those because I have 26 options for all of those places for characters on my license plate. And to find out how many possible license plates there are, you multiply all those together. So we're going to say 26 times 10 times 10 times 26 times 26 times 26.
45.
Keep going. Right. 45,697,600 possible license plates. And I don't think Tennessee's really is that. I mean, we have 6 digits or 6 characters, but I don't know if they're in the same configuration as far as digits and numbers. Okay, grab another one. Hey, put that one on my desk so I'll put calculators in it. Yeah, and just grab another one. All right, so this next one says, How many different license plates are possible if letters and digits cannot be repeated? So again, I need a letter followed by a digit, followed by a digit, followed by a letter, and a letter. Right? Still got to go in that order. I'll move this over. This time, though, we cannot repeat them. So if I use one letter for the first blank, I can't use that letter again. Does that make sense? So how many options do I have for my first letter? 26. And I'm going to skip the digits for a second. I cannot use that same letter again. So now how many options do I have for the next letter? 25. And then I can't use that one again either. So how many options do I have for the next one? And then the next one. Y'all see how if you can't repeat them, how they go down one every time? Because you're taking away the number of options you have after you've already used something. So read for can repeat and cannot repeat. Okay? So the digits, same way. How many options do we have for our first digit? 10. So how many do we have for our second digit? Since we cannot repeat, it goes down to 9.
1.
All right, so we're going to multiply all those numbers together. So tell me, are we going to have more than 45 million in something or less than 45 million in something? Less, because we're multiplying smaller numbers, aren't we? We should have less than 45 million. So just type them all in straight across. What are we getting? $32,292,000 possible license plates. So the number went down a little bit. It's actually a lot because it went down about 13 million. But there's still plenty of options for Texans, right? All right. So remember, if you cannot repeat something, you take away your number of options. Does that make sense? Okay. So let's talk about a permutation. This is an important definition because tomorrow we're going to talk about a combination, and it's a little bit different than a permutation. So a permutation is a listing of objects where order or placement is important. If order and placement matters, if it matters what order we do something in, then it matters. So like say there's 10 contestants in a beauty pageant. It matters who gets first place, second place, and third place, right? Right. First place is queen, then you have first, alternate, second. Okay? You just don't say, okay, you three are winners. No. Same thing with like if you're doing like a competition, like a sport or something. You have a first place, second place, third place. Okay? Order matters. So that's why it's called a permutation. Okay? Here's an example. How many ways can we order the letters A, B, and C? Well, we can do A, B, C. We can do A, C, B. Right? We can do B, A, C or B, C, A.
CAB.
We can do C, A, B or we can do what?
CBA.
C, B, A. Okay? Or we can think of that like we did the license plate. How many options do I have for the first letter? If I'm choosing between my letters A, B, and C, how many options?
3.
3. And I've used one. How many do I have for the second letter? I have 2 options left. How many do I have for the last letter? 1. What's 3 times 2 times 1? 6. How many ways did I get when I listed them all out?
6.
6 ways, right? So 3 times 2 times 1 equals 3 factorial. So this is what factorial is. If you take a number, and we put an exclamation point for factorial, okay? If you take a number and multiply it times every number that comes after it down to 1, that's what a factorial is. taking a number and multiplying it all the way down till you get to a 1. Okay, multiply it times every number that comes after it down to 1. So, for example, this says 2 exclamation point, which is 2 factorial. So 5 factorial means 5 times 4 times 3 times 2 times 1. Now, we can put that in our calculator. Actually, it's going to be 20 times 6 if I group them together, right? Which is 80, right? But our calculator will actually do factorials for us. Huh? 20 times 6 is 120. Sorry about that. 20 times 6 is 120. All right, but our calculator will also do it for you. The way it'll do it without typing them all in, because, I mean, when I do 9 factorial, it's going to take me about 10 minutes. All right, you hit the number in front of the exclamation point, so you hit the 5. Then you hit the math button. Now, well, y'all, where's the math? Everybody should be on their calculator, not any other device at the moment. Calculator should be on. The math button, where is the math button? Under the alpha button. Remember, your alpha one is green, or it could be a different color. So there's the math button. Now, if you look all the way across, you see the letters PRB. And yeah, if you have like a newer one, it actually says PROB. But if you have these old ones, it just says PRB. And you arrow over till you get under PRB, and then number 4 has the exclamation point, which means factorial. So you can either arrow down till you get to it, or you can type 4, and that puts the factorial symbol, the exclamation point, in your screen. So 5 factorial, you hit enter, and it should tell you 120. Okay, so when you get really big ones, like 9 factorial, which means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Instead of popping all those in your calculator all day long, you hit 9, math, PRB, hit 4, hit enter, and it tells you how many. What's that big number? 362,880. Okay, so that's how you put a factorial in your calculator, math PRB. Okay, so here's a word problem to go with that. 10 teams are competing in the final round of the Olympic bobsledding competition. Yes, I loved watching that on the Olympics. How many different ways can the bobsledding teams finish the competition, assuming there are no ties? So what we're doing is we're numbering them from first place all the way to 10th place, right? So I have 10 places for how they're going to place. Is a team going to get first place and 5th place? No, we're assuming there's no ties, and we can't repeat them, right? So for my first place finish, I have 10 options, right? And then for the second one, I have 9. For the third one, I have 8, 7, 6, so on, all the way to 1. So that's the same thing as 10 factorial. And we can just type that in our calculator. So you hit the number, and then math, probability, number 4. If you hit the left arrow button, it'll go backwards. So that's less punching. If you hit the left arrow button instead of the right one. And hit 4 so that you have 10 exclamation point in your calculator. Hit enter. And that is 3,628,800 ways that these 10 teams can finish. It didn't seem like it would be that many, right? That's a lot. 36,288,000. No, I said that wrong. 3,628,800 ways that these teams could finish in order from 1st to 10th place. Wow. 3,600, was it 28? Was that right? Mine won't let me keep them both up at the same time. So word problems need word answers. There you go. Does that make sense why it's 10 factorial? Because it's 10 times 9 times 8, because you can't repeat. Okay. Well, here's another one. In how many different ways can 3 of the teams win gold, silver, or bronze? So I only care this time about gold, silver, or bronze, which is first place, second place, third place, right? So if I have 10 teams, how many options do I have for who's going to win the gold medal? How many teams are in the competition?
10.
So there's 10 possible teams that have a chance of winning the gold, right? Now, if they win gold, can they also win silver? No, you can't win gold and silver medals. So how many options are there for the silver medal? So how many are there for the bronze medal? 8. So if we're doing specific places and we stop after the third, because if you're 4th place, you don't get a medal, do you? Tough luck, you don't. Okay, that's just the way the Olympics work. So we only multiply 10 times 9 times 8.
720.
Look, he's already ahead of me. If it's calculator punching, KD's going to do it, isn't it? So 720 ways to win a medal. Okay. So the next thing we're going to talk about are permutations. Do I have this formula written on your screen or on your paper? Okay. I didn't know if I put it on there or not. And it's in my handwriting because it's not fun to type all that stuff in. So here's our formula for finding a permutation. Now, a permutation is like what we just did. We have 10 teams in the competition. How many ways are there for them to win first, second, and third place? So a permutation, the order matters. It matters who gets gold, who gets bronze, who gets silver, right? I said those by last 2 in order, okay? Because you're just not going to randomly say, you get a gold, you get a silver, and you get a bronze, right?
Yeah.
Doesn't happen. It's not random. Okay? So that's why it's a permutation. If order matters or placement matters, it's important. It's a permutation. So we actually can put these in our calculator. So the way we do it is N is how many you're choosing from, R is how many you're choosing. You might want to write that down. N is how many you're choosing from. Your total. And R is how many you're choosing. Anyways. So you have like a million and you're choosing one, right?
No, I'm choosing 2.
Okay. Oh Lord. So for this race, we could have just done for this competition, this bobsledding competition. We had 10 teams in the competition. We're choosing 3 to win gold, silver, or bronze. So we could type in the permutation in our calculator. The way we would do it is the total was 10. So put your first number, which is your total. You go to Math, PRB, and then you look for the one that says NPR, which is number 2 on my calculator. Hit that. And then you put how many you're actually choosing, and we chose 3, 1 for each medal. And we got how many?
720.
There we go. So that's how you pop it in your calculator.
Oh, gee, this is so easy.
Okay? So you put in how many are you choosing from, Math PRB, how many you're choosing. So these 2 little examples right here, we're just practicing putting them in the calculator. Okay? So y'all practice putting 5P3 in your calculator. 5, Math PRB, NPR, and then
60.
don't tell me, just practice it. Oh, I hit the wrong one. Clear, clear, clear. Mine's difficult because I have to double tap it for it to work. So 5P3. So after you hit that, you hit enter. And what do we get? KD, what'd you get?
60.
60. Does everybody get 60 for the first one? I'm going to make sure everybody's calculator's doing right. All right, then you do 25, math, PRB. Number 2, hit it, enter, and then you hit 6 and enter. Is that a big number?
Yes.
Should be. Good Lord.
27,512,000.
So that, okay, so what does that mean? I gotta, see, my thing won't let me keep it up and write. I'm gonna make sure I write is it 127 million? Call it out to me.
127,512,000.
Okay. So that means if I have let's say I have 25 students in my room, and I'm telling 6 of you to go line up in a specific order, there's that many possible ways that can happen.
What? How?
Because it follows this formula. You take the number they are, factorial.
Yeah, I know.
So that's 25 times 24 times 23 times 20, all the way down to 1, times n minus r factorial. So that would be 25 minus 6, which would be 19 factorial. So it would be 25 factorial divided by 19 factorial.
25 minus 6 is 19.
Yeah. Well, I just told you what it was and saved you much time.
I was 2 seconds.
So anyway, that's why those numbers get really, really big, because it follows that formula. The calculator does the formula for us. Yes. Word problems. Okay. Well, they're on their paper. We're just going to put it in. You're burning a demo CD for your band. Your band has 12 songs stored on your computer. However, you only want to put 4 songs on your CD. How many orders can you burn 4 of the songs onto the CD? Okay, we're not trying to be random here, okay? Because, I mean, if I'm making a good CD, I'm not going to put all slow songs on my CD, right?
Turn songs on that.
Yeah, see, I want a turn song on my first track because that's going to catch your attention,
Yeah.
right?
Your intro.
Right? Okay,
Yeah.
I want something good to catch your attention. Now, if I have a nice little slow love song, I might put it on there, but I'm not going to put it on there first long because you driving down the road and you put in a CD. I know that's old fashioned to put in a CD, but anyways, I play it on my iPod on my playlist, and I turn to an album. I don't want the first song to put me to sleep when I'm driving down the road.
You rig into a train.
Exactly. Well, whatever. Okay, so I need something that's going to be catchy and fun and turnt, like you said. Okay. So anyway, so that's why it matters what order we put songs on a CD. This isn't a mixtape. Okay? I actually want to be a good band that makes money someday. All right? Yeah. So, how many do we have to choose from? How many total songs do we have to choose from?
12.
So that's my first number.
12.
And so we're going to say P. And how many are we picking?
4.
4.
Equals.
So do y'all see how we set that up?
Yes, ma'am.
It's P because it's permutation because the order matters. This is the total. This is how many you're going to pick. And then you put that in your calculator.
11,880.
Hang on. I want to see what my calculator does. Because it does a little different. Oh, it does the same. 12P4. How many different ways can we make this CD? 11,880 possible CDs. Yeah, possible ways to make the CD. Does that make sense?
Yeah.
Okay. Here we go. How many orders can 4 raffle tickets be selected from 50 tickets if each ticket wins a different prize? So it matters who gets what prize, right?
Yeah.
Yes.
All the time.
So it's 50P4. That's right. So your left number is always your total. So 50P4. Is everybody getting these plugged in right?
5,527,000.
5,527,000. Say it again. 5,000,000.
527,200.
Winners. I'm going to say possible ways to win prizes. Well, I'm an overachiever. To win prizes. Yeah, there you go. Okay. The last thing we have to talk about is permutations with repetition. So we should be at the last page, the back page of your notes. Your typed out notes. All right. It says find the number of distinguishable permutations in the letters Miami. Now this is repetition because the word Miami has some letters that are repeated. Right? What letters are repeated in Miami? I and M. Yeah. Okay, so here's what you do. First, you say how many total letters there are. 1, 2, 3, 4, 5. Right? So that's 5. No. You're going to say 5 factorial. Divided by what letters are repeated?
M and I.
M and I. How many M's do you have? 2. And then how many I's do you have? So that's what you're going to do. You're going to do 5 factorial divided by how many you have repeated. So you have 2. These are the M's and these are the I's.
I got one.
Okay? So in your calculator, and I'm going to double check from my book to make sure I'm doing it correctly. So you can do 5 factorial, which is 120. And then you can do 2 factorial times 2 factorial. Well, isn't 2 factorial just 2? 2 factorial means 2 times 1, right? So 2 times 2 is what? 4. And what's 120 divided by 4? 30. So there's 30 possible permutations in the letter arrangements in the word Miami.
I put all of it together and I just got 120.
You typed it all straight in, you're going to have to use a lot of parentheses. So I would do the numerator and then the denominator. Let's see if we can do it on the next one. Tallahassee. Cities in Florida, I guess was the category here. How many total letters are in the word Tallahassee? Y'all agree? Okay. So 11 factorial goes on top. Now, what all letters are repeated? An S, right? So you're going to divide by the ones that are repeated. So how many A's do you have?
2.
Count again.
3.
So we have 3 factorial for the A's. How many L's do we have? How many? 2 L's. Oh. I'm trying to write underneath it which one it stood for. How many S's?
2.
2 factorial for S's. And then we have E. How many E's do we have?
2.
2. I'm going to do it numerator and then denominator. So for the numerator, I'm just going to hit 11 factorial. You get a really big number, don't you? So I'm going to write down that number.
39B9.
Is that right? And on the bottom, sorry, I'm covering up my stuff. I'll come over here. You're going to type in 3 factorial times 2 factorial times 2 factorial times 2 factorial. Save you some writing. What's 2 factorial, y'all? Just plain 2, right? Yeah. So you can do 3 factorial, which is actually just 6 because it's 3 times 2. And I'm just going to show you how to punch it in. I forgot my 3. Crap. So you hit 3, math, PRB. That's my problem. A lot of times I forget my first number. So 3 factorial times 2 times 2 times 2. Hit enter.
48.
48.
Put it under the 9.
So that goes below it. So you're going to do
800 divided by 48. If you're going to get 831,600.
I'm believing you. 831,600. Y'all get that? Good.
Yeah.
Yep. So that's how many different ways you can rearrange the letters of
Oh, they lied now.
Tallahassee. And there's less. We had a divide because some of these are repeated, right? So a different A could still be an A in the same place. I want y'all to try it for Atlanta. Try it by yourself for Atlanta. My favorite city. Besides Selmer, Tennessee, of course. Instrument.
Ooh, the answer was mine. I just gave it down to you.
And I try to avoid that number.
27 is it?
Don't worry about it.
You don't need me.
Okay.
Oh,
Rolling my eyes. Don't say anything incriminating. You're recorded.
I was so to say something.
Don't do it. All right. So, how many total letters are in the word Atlanta?
7.
So, it's 7 factorial. What letters are repeated?
The A and the T.
A and the T. How many options do we have for A's?
3 A's and 2 T's.
And 2 T's. So, did y'all do 7 factorial divided by 3 factorial times 2 factorial?
7 divided by 12.
5,040 divided by, you got 12. You could type those in your calculator and multiply them together. Or you could say that's 6, that's 2. If they're small numbers, I memorize them. And you divide by 12. And you get how many? 420 ways you can have permutations of the letters of spelling Atlanta. So that's how many different ways you can spell letters with those 7 letters. Okay, so our practice. We're going to end the video. Have a good day.